This is Pat Obi at Purdue University Northwest, and I'm going to show a quick example of how to perform a unit root test on EViews. And I've summarized the command right here. Now, as you know, the null hypothesis is that the time series that you have on hand has unit root. In other words, it is non-stationary. As you know, a non-stationary time series can lead to spurious correlations when used in econometric modeling. Now, to perform a unit root test using the augmented Dickey-Fuller approach, we have a choice as to whether to include a constant term, which is the intercept or the drift parameter, or both constant and trend, or none at all. And as you can see the summary of the respective equations right there. Now, when you do a unit root test, if you accept this null hypothesis, in other words, if you do not reject it, then you're saying that you do have unit root in the series. Now, to make a determination, though, as to whether, nevertheless, the series can be used in econometric modeling, you want to look to see if stationarity is achieved after first differencing the series. And so to show this example, I'm going to use the data series that you see here. These are 1 month crude oil futures prices from 2010 up to 2016, as you see right there. All right, so what I'm going to do is I'm going to copy this over to eViews, and I already have done that, and I've named it oil. And if I double click it, you see the series right here. Alright, so to perform unit root tests, I have a couple of ways to do so. One is you can click on Quick and then go to Empty Group. Go to Group Statistics. Alright, hover your cursor right here. Actually, I'm sorry, you go to Series Statistics, right? I suppose if you check one, it's not that, you just simply move on to the next. But anyways, so you hover your cursor on it and then you move it along to unit root test. And you type the name of your series there. In my case, it's oil. Okay. Now, you can, if you click on this pull down arrow in this dialog box, you see additional types that you can use. Phillips parent is also quite and an Eng parent, those are quite popular, but I'm going to leave it at augmented Dickey-Fuller. And first we're going to test for unit root in the level series, which is the series I just showed you. And for lag length, leave it at automatic selection, and it's going to be based on the Schwartz information criterion. If you want to look at other criteria, just click on this and you'll see a bunch of them right here, including one that's particularly popular, at least initially, the Kaiki criterion. Alright, so here are the assumptions, and one way to kind of get a sense as to whether the series may have a trend is, let's kind of pull this aside. We can go here. Okay, let me get out of this again. So we can go here to View, choose Graph, and let's stay with this line graph right here. And I don't see any trend in crude oil prices in the years from 2010 to 2016. Right? I see a sharp decline here, but really there's no discernible trend. So I'm just going to leave that alone. All right, so I'm going to go back here to Quick, Series Statistics, unit root, and I'm going to type oil again, and OK. So I'm just going to again click on level. All right, leave it on intercept only, and then click OK. And that's your result right there. So as you can see, we cannot reject this null hypothesis that the series has unit root, because the p-value, which you see right here, is way more than 0.05, way more than 5%. So series has unit root. Series is non-stationary. So what are we going to do? Well, let's see whether whether stationarity is achieved after first differencing the series. So we're going to go right back over here to Quick, Series Statistics, unit root, again type oil, OK, and now I'm going to click first difference and click OK. And voila, you can see now that the first difference series, all right, D all, has unit roots. Sorry, no longer has unit roots. We have to reject this null hypothesis right here that the difference series has unit root, because the p-value which you see right here is way less than 5%. Right? In all cases, just make sure that the sign of this coefficient that you see here is negative. All right, and that's really it. Now though, one final thing. Now you also can, when you click on this series, when you bring it up, you can go to View and choose Unit Root Test. There you go. You have the same dialog box. All right, that's the result for Unit Root Test on the level series. And then you go back to View, Unit Root, click on First Difference, and here's your result again. All right, so you really didn't have to go all the way to Quick and do the series statistics and unit root there. All right, so this concludes this exercise.